Question A asks us to write the equilibrium constant expression for the reaction represented above. So the format is K is equal to the concentration of products over reactants. So we really just have to plug the elements in. So on the product side, we have ammonium, which is NH4+, and that's on top, and OH- hydroxide, and that's also on top. And on the bottom, these are the reactants. And we have ammonia, which is NH3, and that's on the bottom. And we do not include H2O or water because it is in a liquid state, and liquids do not affect equilibrium. Question B asks us to determine the pH of the 0.081 molarity NH3. So in the description, it gives us that the concentration of hydroxide was 5.6 times 10 to the negative 4th. And you can find pOH using the molarity of hydroxide. And that equation is pOH is equal to negative log of the concentration of hydroxide. In this case, it's 5.6 times 10 to the negative 4th. So I put that in. In the pOH, I got was 3.25, but it asks for the pH. So we have to subtract 14 from that number. So we end up getting a pH of 10.75. Question C asks us to determine the value of the base ionization constant Kb of NH3. Now to do this, we're going to use the equilibrium constant expression we got in question A. And we're just going to plug some numbers in. And in the description, it gives us the concentration of the OH-, and the concentrations of the hydroxide and the ammonium will be the same in this case. And on the bottom, we have the reactants, which is NH3. And the molarity of the NH3 is 0.018, so that's why you see this there. And then we subtracted the molarity of the NH3. But since this number is really small, this number is really insignificant, so we can just cancel that out. And we end up getting a K of B value of 1.74 times 10 to the negative 5th. And question D asks us to determine the percent ionization of NH3 in 0.018 molarity NH3. And so the equation for percent ionization is the concentration of ionized acid divided by initial concentration of acid times 100. So in this case, the concentration of the acid was 5.6 times 10 to the negative 4th. And we can see that from this problem. We use this value in this problem for that NH4, which is the acid in this case. And then we divide it by the initial concentration of the acid, which is 0.01 molarity, which we found in the description. And then we times that by 100 to get 3.11% ionization. And since this number is below 5%, we do not have to recalculate this with the 5.6 times 10 negative 4th. Because if it was above 5%, then it would be significant enough to alter the percent ionization.